All right, so today we're going to start talking about sections 4.2 to 4.3, triangle congruencies. There are three postulates and one theorem you need to know about. The postulates: 4.1, if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. 4.2, if the two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. That's SAS. And then the third one, 4.3, two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, and the triangles are congruent. That's angle, side, angle. There is one theorem. All right. If two angles in the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. All right. And then those are the abbreviations. So basically what each one looks like, notice in the first one, there's no angles given. So that, ladies and gentlemen, is what side, side, side looks like. All right. If we look at the one next to it, we got two sides and an angle. The angle touches both sides, so therefore, all right, we have what's called side, angle, side. It's very important that the sides of the angle have to be the congruent sides. So this would be side, angle, side. Underneath, well, above it, it says angle, side, angle postulate, so this must be angle, side, angle. So two angles and included side are congruent. So basically, their roles reverse. The side now touches both angles. So that's what angle, side, angle looks like. And then finally, A, B, C, and D, F in the last diagram. It's two angles and a side. The difference is the side only touches one of the angles. Well, by third angle theorem, which we talked about in 4.1, if the two angles are congruent, then so is the third pair. So A's got to be congruent to D. As a result, this would be angle, side, angle. So to save ourselves the time of having to use third angle theorem and saying the third pair of angles is congruent, all right, instead we just call it angle, angle, side. It's a theorem, not a postulate. You don't have to distinguish between the two when doing proofs, and you got everything you need to know. Now, your job is going to be twofold when you do these. Number one, identify the triangle congruency statement. So basically, you're going to say ABC is congruent to DEF triangles, and then you're going to explain why using one of those four. Again, you don't have to distinguish between postulate or theorem on the quiz, on any assignments or any proofs. All right, so to do this, the first thing we do is restate the given. All right, so if they give you congruent information, you say you have to restate it, and the reason being is given. Use any justifications, use any definitions to justify any segments or angles are congruent. All right, so basically, all right, if they tell you something's a midpoint, well, definition of midpoint says the two segments are congruent. If an angle bisector, things like that. So vocab. Identify things we are allowed to assume are true from a diagram. This, for the most part, is going to be if we have linear pairs and congruent supplements or vertical angles. All right, and then identify which postulate or theorem can be used to match up correspondings and sides or angles in your congruency statement. All right, so that's the last part to these proofs. We'll add to that as we advance in the proof writing stages, but that's what we're looking to do. All right, some quick things. If you look at it, would you use SSS or SAS to prove these triangles congruent? If there is not enough information to prove the triangles are congruent by SSS or SAS, write not enough information. Explain your answer. So, if I look at this diagram, as mentioned in the 4.1 notes, we have what's called a shared side. So then we say that segment's congruent by the reflexive property. And then those triangles are going to be congruent by side, side, side. If you look at the one next to it, we got intersecting lines. As soon as you see intersecting lines, you should think of vertical angles. The vertical angles are going to be congruent, so the two triangles are going to be congruent by side, angle, side. All right. As we put that into a proof, copy and complete the flow proof. So Rx is congruent to Sx. All right? Because it is given to you. QX is congruent to TX because it is given to you. All right. The third thing we have is angle RXQ is congruent to angle SXT. Okay. That is because of the vertical angle property. You can use vertical angle property, vertical angle theorem. You can say vertical angles are congruent. The one thing you cannot say is definition. The definition of vertical angles never mentions congruency. By the way, you can also call them 1 and 2 if that's easier for you to write your proof. At that point, we can put that all together and state that triangle QXR is congruent to triangle TXS by side angle side. The angle touches both sides. As a result, we can say the two triangles are congruent, and you can only hope that proofs are that straightforward because they probably won't be. Now, one little note, instead of given, what vocab term could they have used to provide the given information? So basically they said that segment's congruent to that segment, and that's okay. That's the same thing as saying X is a midpoint. So if they told you X is a midpoint of RS and or QT, it would say the same thing. But please keep in mind, if they tell you it's the midpoint of one, it doesn't necessarily mean it's the midpoint of the other. All right, next proof up. Okay. It says BD is the perpendicular bisector of AC. Triangle BAD is congruent to BCD. So BD is the perpendicular bisector of AC. That is given. Number 2, we could say AD. Is congruent to DC. Definition of segment bisector. Now, ADB and CDB are right angles. That is the definition of perpendicular. We can then say angle ADB is congruent to CDB because all right angles are congruent. All right. In the PowerPoint, we do it a little differently. You can combine those into one step. So if you check the PowerPoint and you have a question about that, please let me know. All right, so that means these two angles are congruent. Those two sides are congruent. BD is congruent to BD. If you want to write reflexive, that's fine. If you want to write shared side, that's also fine. And that is enough to tell us that triangle BAD is congruent to triangle BCD by side angle side. And there we go, because the angle touches both sides. The sides of the angle are the congruent sides. Now, what other information do you need, if any, to prove the two triangles are congruent to by side angle side? Explain. To start, list the pair of congruent corresponding parts you already have. So in the given, they are telling us AB with one tick mark is congruent to HG, which also has one tick mark. BC, which has two tick marks, is congruent to either FG or GF. Okay, so for us to use side angle side, it's got to be the angle between the sides, so it would be those. So we would have to say angle B is congruent to angle G. All right, now the one next to it, all right, we have X is Z with the two tick marks is congruent to RT. We have YZ is congruent to TS. All right. And then finally, we have angle Y is congruent to angle S. Now, side-side angle does not exist. That's what this is. So we can't justify. So we would need a side. So if we went XY was congruent to RS, that would give us those sides. Then the angle touches both sides. It would be side angle side. Or angle Z is congruent to angle T, because then the two sides in the included angle would be congruent. So either one would give us congruent by SAS. Can you prove the triangle is congruent? If so, write the congruent statement and name the postulate you would use. If not, write not enough information and tell what other information you would need. All right, so the one on the left, number 8, is fine. QRS is congruent to triangle YXW. It is important you follow the same order. QRS goes 1 to 2. So if I go 1 to 2 over there, it's YXW. All right, and that would be the SAS postulate. Now, number 9, They give us two sides. They look congruent, but they have to give us more information. Well, they don't. So we write any I for not enough information. If they told us that FH was congruent to HK, then we would know it was congruent by side, side, side. It would be side, side, side. If they told us that angle G was congruent to angle J, then it would be side, angle, side. All right, so we would need other information. So since they don't give it to us, that would be any I. All right. Okay, so that's it for that video. We'll shortly put another one up for the remainder of the packet.